definitely is static electricity season in physics with our charge study guides. With page 7, refer back to the activity with foam cups and develop a model for the basic law of electrostatics. Well, your basic law of electrostatics is something you've been well aware of for many years. You just haven't probably had a name attached to it. And the basic law of electrostatics is the fact that like charges will repel and opposite charges attract. Hence, on the cover of your study guide within charge, we have this negative sign all blazoned throughout, as we're going to be focusing mostly on electrons, which are the negatively charged items within an atom. So the basic law of electrostatics, like charges repel, opposite charges attract. And again, you've been pros at this for many years. I hope you don't do this to your pets. Pets are awesome. In fact, my favorite thing about people are their pets. Pets aren't necessary for static electricity demonstrations. You've probably experienced combing your own or brushing your own hair, and your hair goes wild. And you can take that charged comb, so charge meaning you ran the comb through your hair, or with your experiment with the foam cups, probably took the foam cup, rubbed it against shirt or pants, and then take the charged comb and you can hold it over these pieces of tissue paper, and those papers will seem to kind of dance and jump to the comb. And when it comes to the phenomenon static electricity, you can do much more than just pull water or have wild hair. And we're going to show you a video where someone has done 9 experiments with static electricity that perhaps you've not thought of before. This classic physics instructor is going to walk you through the basic law of electrostatics as it applies to the foam cup experiments that you did. And instead of foam cups, he just has large balloons.
Give a charge to the balloon, collect a like charge on my balloon, they repel, at closer approach more, bigger force, now farther away less force, still farther very little force. Now give an opposite charge and I get attraction.
Of course, when you think classic physicist or perhaps classic scientist, you might think of...
Oh, hi. Rub a balloon on your hair and bring it near another balloon hanging by a string. There's an invisible field pushing the two balloons apart. When you rub the balloon on your hair, you're transferring electrons from your hair onto the surface of the balloon. Now, the balloon's made of rubber. Electrons don't flow through it the way they do through a metal wire. Instead, they stay on the surface of the rubber. We use the word static electricity, which means electricity that stays. Now, different materials have different properties. Here's a stiff rubber rod and a piece of fur. It's like rubbing a rubber balloon on my hair. It also will push the balloon away. But watch what happens when I use the same piece of fur and this glass rod. It pulls the balloon toward it. So in the first case, we say they have like charges, like static charges, so they repel. In this case, they have opposite static charges, so they attract. You can try different materials and different experiments. Here's some rubber making scraps of paper jump around. It's fun. Or you can try 2 at once. Here's a repelling rod and an attracting rod. Repelling, attracting, repelling, attracting. I'm experimenting.
And through your various experimentations, like Bill and I was doing, you soon come to realize that different materials are able to be better at transferring the energy, the charges, from more positive to more negative. You get lost in looking at all the lists of these that are called Triboelectric Series, ranking materials from their ability to more readily give up their electrons to not so much readily transfer their electrons. Hopefully there's some information that will help you in the work on page 7 to refer back to the activity with the foam cups and develop a model for the basic law of electrostatics. How your foam cup observations showed that like charges repel, opposites attract. Remember, when you're making a model, you need to identify the components, label the sketch, and essentially is identify the relationships so that you can make connections to explain what's going on. So someone could look at your model and understand the basic law of electrostatics.